Have you ever stopped to wonder what happens to light after it enters your eyes? Every second of every day, billions of particles of light travel from the world around you into your eyes, allowing you to see faces, colors, movement, and incredible details. But the journey of light inside your eye is far more fascinating than most people realize. The process begins when light reflects off objects around you and enters the front surface of the eye, known as the cornea. The cornea is a transparent dome-shaped layer that acts like the first lens of a camera. As light passes through it, the cornea bends and focuses the incoming rays toward the center of the eye. Next, the light travels through a clear, fluid-filled space and reaches the pupil, the dark circular opening in the middle of the eye. The size of the pupil constantly changes to control how much light enters. In bright sunlight, it becomes smaller to reduce the amount of incoming light. In dim environments, it expands to allow more light inside. Surrounding the pupil is the iris, the colored part of the eye. The iris functions like the aperture of a camera, automatically adjusting the size of the pupil to maintain the right amount of light for clear vision. After passing through the pupil, light reaches the lens. Unlike the fixed lens of a camera, the human lens can change its shape. Any tiny muscles surrounding the lens contract and relax, allowing it to focus on objects that are near or far away. This remarkable process is called accommodation. The lens then bends the light even further and directs it toward the back of the eye. The goal is to focus the light precisely onto a thin layer of specialized tissue called the retina. The retina is where light is transformed into information the brain can understand. Covering the retina are millions of light-sensitive cells known as photoreceptors. These cells are divided into two main types, rods and cones. Rods are extremely sensitive to light and help us see in dim conditions, such as at night. However, they cannot detect color. Cones, on the other hand, are responsible for color vision and fine detail. Different types of cones respond to red, green, and blue wavelengths of light, allowing us to perceive millions of colors. When light strikes these photoreceptor cells, an extraordinary chemical reaction takes place. The energy carried by light is converted into tiny electrical signals. At this moment, light itself effectively disappears, transformed into neural information that can be processed by the nervous system. These electrical signals travel through several layers of retinal cells, where the information is organized and refined. The retina begins analyzing patterns, brightness, contrast, and movement before the signals ever leave the eye. Once processed, the signals converge at the optic nerve, a bundle containing more than 1 million nerve fibers. The optic nerve acts as a high-speed communication cable, carrying visual information from the eye directly to the brain. The journey doesn't end there. The signals travel to specialized regions deep within the brain, particularly the visual cortex located at the back of the head. Here, the brain reconstructs the incoming information into the images you experience as sight. Remarkably, what you see is not a direct picture captured by your eyes. Instead, it is the brain's interpretation of electrical signals generated by light. Your brain combines information about color, depth, motion, shape, and previous experiences to create a complete visual representation of the world around you. All of this happens in a fraction of a second. From the moment light enters your eye to the instant you recognize an object, countless biological processes occur with incredible speed and precision. So the next time you look at a sunset, read a book, or recognize a familiar face, remember the extraordinary journey that light takes through your eyes and into your brain. Every image you see is the result of one of the most sophisticated biological systems in the human body, transforming simple light into the rich visual world you experience every day.